Hi students, today we will discuss the derivation for the capacitance of a parallel plate capacitor when a dielectric of dielectric constant K is inserted in between the parallel plates. So this is a important derivation. It may ask in your CBSE exam. So you see here how to derive. As you already know, if a parallel capacitor is there, then in between these two plates the electric field is uniform, and this electric field is equal to sigma by epsilon naught, where this sigma is your surface charge density. This already you know. So now you see how to derive. Suppose we are assuming a parallel plate capacitor each having charge, suppose plus q minus q, and the separative distance between them is d. Then suppose the cross sectional area is equal to a, and as this is positively and negative charge, so direction of the electric field will be from this side to this side. So this is the direction of the electric field. Suppose that electric field is E naught. So now you know the electric field inside the two parallel plates, this is equal to here E naught equals to, you know, sigma by epsilon naught, where your sigma is the surface charge density and epsilon naught is the absolute permittivity of air. So this epsilon naught is equal to, you know, here 8.854 into 10 to the power minus 12, and this sigma is your surface charge density, so this is equal to your charge upon area. These things already you know, right? Now suppose we are inserting a dielectric of thickness T. The thickness of this dielectric is here, suppose T, and when we are inserting a dielectric, you already know the behavior of a dielectric in a electric field. So if a dielectric is inserted, then due to polarization the opposite charges will develop in opposite sides of the parallel plate capacitor. So you can observe here, so this is your positive charge, so that means this is your negative charge on the capacitor. So for the dielectric the oppositely charge will be induced due to polarization. So here this will be negatively charged, right, and this will be your positively charged. This will be your positively charged. Understood? So now you see inside the dielectric the electric field is opposite to the applied electric field. So this is suppose here EP, that is electric field intensity due to polarization in a dielectric. So in between the parallel plates we have a region of the dielectric, and inside the dielectric the net electric field intensity will be, that is inside your dielectric, inside dielectric. What is your electric field? This will be your E naught minus EP. And why this is E naught minus EP? Now you can understand that EP is in this direction, E naught is in this direction. So the resultant electric field intensity in this inside the dielectric, this will be equal to E naught minus EP. So this is also equal to, if the dielectric constant is K for this dielectric, this is K is equal to your dielectric constant, then this E naught minus EP is equal to your reduced electric field, and its value will be E naught upon K. E naught upon K. So that is E naught upon the dielectric constant. Now you see, we have find out that electric field inside the dielectric, that is reduced, and its value is E naught by K, and it is affecting the thickness of T. So other than this thickness, the remaining thickness is your D minus T, where the electric field intensity is the external electric field intensity, which is produced by the parallel plates of the capacitor. So now we know what is your potential difference. What is your potential difference? The potential difference we find by electric field intensity into the distance. So in this case, we have two regions. One is inside the dielectric and another one is the outside the dielectric. So outside the dielectric, we have the electric field intensity E naught, and inside the dielectric, we have the reduced electric field, that is E naught by K. So the total V will be equal to E naught into D minus T plus, this is the reduced electric field, that is E naught minus EP into T. So here we can write E naught into D minus T plus, this will be E naught by K into T. So here if we take E naught common, so this will become as D minus T plus T upon K. So this is the potential difference between the two plates when the dielectric is inserted. Now what is the capacitance? You know the capacitance value is equal to here Q upon V. So here this will be your Q upon V. So you know what is Q? Q is, if we are considering the surface charge density as sigma, so the value of Q will be equal to sigma into A upon V. So for V we can write this one. So this is E naught D minus T plus T upon K. So this will come as sigma A. Now for E naught, what is E naught? The electric field between the parallel plates, that is the uniform electric field. So this is sigma by epsilon naught. So here we write sigma by epsilon naught. This is D minus T plus T upon K. So here sigma cancels out. So this will be epsilon naught A by D minus T plus T upon K. Right? So this will be your capacitance. So now we can tell here that the capacitance of a parallel plate capacitor is going to increase if a dielectric is inserted in between the parallel plates of a capacitor, right? So if there is a condition, if the dielectric is completely filled in between the parallel plates, then you can understand the thickness of the dielectric we can consider as D. So if the dielectric is completely filled, if the dielectric is completely filled, then what will get? Your T will be equal to your, that is D. So putting this value in this equation, we can find your C will be equal to your epsilon naught A upon D minus T. For T will write D plus T by K, so that is D upon K. So now this will come as D cancels out. So D upon K, so K will be shifted to the numerator. So this is K epsilon naught A by D. So what we get here, this will be K into C naught. That means the capacitance is increased K times. So now here we can conclude that if a dielectric is placed in between the plates of a capacitor, the capacitance is increased, and the formula to find out the net capacitance, C equals to, that is epsilon naught A upon D minus T plus T by K. And if the dielectric is completely filled, then the capacitance is increased k times. So I think all the concepts are clear. You can write, you can derive the derivation easily. Thank you.